Well, good morning, afternoon, evening for those joining overseas. Welcome to our second webinar in our ongoing series on the future of global AI governance. My name is Peter Stockberger. I'm the managing partner for the San Diego office of Dentons. And with me today are three esteemed panelists and experts in the area of artificial intelligence. Gabriel Rene, who is the CEO of Verses. We have Philippe Saeg, who is the chief adoption officer for Verses. I believe I got that title right, Philippe. And George Percival with the Spatial Web Foundation. We are going to focus today's webinar on really doing a deep dive on the future of public policy and where the global community is heading around artificial intelligence. Anybody paying attention knows that in the past week, we've had some very significant global developments around artificial intelligence and in the regulatory space. And so we're going to break those developments down. We're going to really ask the question of, is the world heading in the right direction around AI? And I know all of us have some opinions about that. And we're going to be talking about what the future of AI regulation looks like in this fast-changing environment. So with that, I just wanted to set the table with some of the developments that occurred last week in the space of AI, and then toss it over to the panel to start to break these things down. I'll just give a brief snapshot. Last week was really a landmark week across the globe with regard to developments from regulators and policymakers around AI. We had the White House release their first of its kind executive order on October 30th, directing the federal government apparatus to examine ways in which the federal government can use AI in what they're calling a responsible or trustworthy manner. So the executive order does a number of things. It's 111 pages. It talks about different federal agencies and their role in developing policy of AI. And really the White House put this out because there's been this debate within the US as to what's the proper direction for the federal government and the states to look at development around AI policy. So the executive order doesn't necessarily impact private industry, but it does impact federal agencies. Building on that executive order, we had a UK AI Safety Summit that was held in the United Kingdom. It was a limited universe of participants, about 100 leaders in AI, including heads of state. And what came out of that summit was a declaration signed by 28 countries, including China, the EU, the US, signing a declaration pledging to develop responsible and safe ways to use AI. So not a lot of detail in that declaration, but an important development nonetheless. And then the third development, then I'll toss it to you guys to break these things down, is we saw the G7 through the Hiroshima process come out with their recommended code of conduct. So a lot of development right now on the global stage, a lot of folks wrestling with the right way forward on AI regulation. And I wanted to actually open the discussion up for a question for all three of you. And Gabe, we can start with you. With these developments last week, the executive order, the UK AI summit, the G7 release, and obviously all the flurry of activity we're seeing, what are some key takeaways in your view from what happened last week? What does this mean for the public policy discussion moving forward?
Thanks, Peter. It's great to be here again. And I think the top line here is that governments are taking AI technology very seriously. I don't think we've ever seen this kind of mobilization in government and in regulation at this scale before, and so quickly. I mean, let's flash back to just a little less than a year ago when ChatGPT came out. I think it was early December. And all of these really accelerated efforts by government around trying to look at what I would argue is ultimately going to require comprehensive AI policy at the global scale is really advancing rapidly. And so you're seeing this sort of various powers that be in the US, G7, the UK, kind of taking their own unique stance. And fundamentally, where everyone is at the moment is offering a set of principles. We're at the, hey, here's some broad guidelines under which we should consider how to develop standards, which will be more specific, which we will consider then how to, enable compliance or ensure compliance and enforcement. And the real problem space ends up in the compliance and enforcement end of the trail here. And we're quite far from there, but I think it's an important first start.
Philippe, I'll toss it over to you next. I mean, what was, Gabe talked about, it looks like everyone's focused on a principles-based approach potentially, or a risk-based approach, but what are some key takeaways that you gathered from these global developments?
So it was interesting to observe, I mean, being based out of Europe, the narrative around AI started with the EU AI Act as well, quite some time back, with some focus also on the privacy side of the house with the GDPR. So AI is being center stage at a global level right now. What's interesting from a policy standpoint is that we are starting to see emerge consensus to a certain extent on principles, as Gabe mentioned. But regionally speaking, the impression is that governments and regions are still trying to struggle with their local specificities and trying to angle that in a way that's relevant to their market. It feels at this stage that a global consensus is not there yet. And the second observation is that, and this is something that we explore in the report, is that most of these policies are based on what everybody's calling principles and standards. We're looking at this from a socio-technical standards, which is something very different. We're looking at not necessarily governing the actual players, so developers and companies, but actually focusing on the actual algorithms themselves. So we're still at a high level and trying to work towards a global consensus.
So Philippe, I think that point about the distinction between this conversation around principles and a conversation around standards is an important one. And George, I want to come over to you because you are part of the Spatial Web Foundation working on standards in this space of AI. And before we do, George, I just want to mention to the audience, if you do have questions, you can populate them in the Q&A box, and we'll be happy to pepper them in through the conversation. But George, on this distinction between the principles-based approach and standards, when you look at the White House's executive order, there is a specific provision in there where they call on the Department of Commerce to work on consensus standards for industry and also work on developing global cooperation toward the development of technical standards. They use the phrase global technical standards around AI. George, I was wondering if you could break that down for us. What is the White House talking about when they're talking about global technical standards? And what are you all working on at the Spatial Web Foundation in this space of AI standards?
Yeah, thanks, Peter. And the language of the executive order is very well crafted. It's based upon the development of standards in the past few decades and the like, moving away from what we would call government standards. There was a time that the government, US government, developed what are called military standards, MIL standards. And some time ago, they shifted from that to the phrase that we now see in the executive order, which is that NIST shall establish guidelines and practices with the aim of promoting consensus industry standards. So what does that mean? It means, first off, it does not call for NIST to establish standards. It calls on them to establish guidelines and best practices, which they will then use in promoting consensus industry standards. That's the other key phrase, consensus industry standards. So industry standards means those set of standards developing organizations which involve industry in a very heavy way and in a leadership kind of fashion that allows for innovation, industry innovation to come into those standards. So industry standards. And the NIST directive, the directive to NIST, is to organize the government, involve broadly, like through the upcoming consortium that NIST has announced, gather that and contribute it to industry standards, consensus industry standards. So let's add that other word, consensus, And that means not just what the biggest players are doing, but addressing some of these other aspects like the socio-technical aspects, which Philippe just referenced. And so some leadership of government for sure, and NGOs on issues like privacy, equity, and civil rights that are all called out in that executive order is a key to getting this consensus. And so what does that mean? We need to work with NIST and look forward to them bringing those kinds of guidelines and best practices to industry consensus standards like the IEEE. And so that's where we, with the Spatial Web Foundation, who have been working with IEEE as a open standards development organization, are a bit of ahead of the game in that regard. We can point out a little bit later where the executive order needs to be stretched. But in this regard, about directing the government to get involved in industry consensus standards, get involved in a global participation about standards is spot on, and we look forward to working with them.
Yeah, George, when I hear the word standards, and I'm coming at this, I'm a tech lawyer, but you guys are the technologists. So you understand the technology. I understand some of the rules around technology. But when I hear the word standards as an attorney, I think of technical standards that, for example, the IEEE has promulgated over the years, and around electricity, around Bluetooth, around Wi-Fi, these technical standards for industry. And Gabe, I want to bring it back to you here. This concept of standards, and I know Philippe mentioned socio-technical, which is a different form, and then we have technical, but we have this concept of standards, which sounds like it's one path. But we see a lot of policymakers and regulators talking about responsibility frameworks. Hey, company A, if you want to use AI, be responsible and adhere to this framework. And so we've got, Gabe, we've got one path of the conversation talking about responsibility and putting the onus on the business or the organizations. And we have this separate path that George and Philippe mentioned about creating standards, which the White House seems to endorse. But Gabe, how do you merge the two? Are they complementary? Do you see them diverging? Is there a conflict? Where do you see that playing out as we look at the future of regulation in this space?
Well, it's interesting because for the first time, perhaps in the history of society, and let's call it the history of technical standards, which, as you pointed, a lot of that emerged at the end of the Industrial Revolution around electrical standards and production standards, manufacturing, as large scale things that we built could affect large populations. And so ultimately, these technical standards organizations like IEEE or the International Standards Organization, ISO, there's ones for Geospatial Consortium, which George is a former CTO of, which does everything related to how we do GPS tracking around the world, and so that will work globally. It's a bunch of countries, a number of satellites. Standards end up forming this sort of bedrock upon which honestly laws are drafted. So even building something to code, means building on the IEEE standards that apply to electrical grounding in a building in the United States or across most of the world. Right now, everyone's talking about responsibility, values, ethics, democratic concerns, even intellectual property concerns, which sort of dip into the sort of ethical factors. And so we get words like responsible AI. That's not a technical term. Responsible is a social term. And so classically, we have social organizations that are interested in social activities, and everything from human rights to animal rights to larger societal organizations, the World Economic Forum and others. And then you got technical organizations, and never the two shall meet. There hasn't been an intersection. In Web 2.0, we all saw what happened to society when social technology, social media, suddenly became something that much larger than any nation state in terms of the total number of participants and users, and how that affected the culture more broadly. Legislation was late to the game there, and we're still sort of trying to pick through the pieces, and really not a whole lot of meaningful legislation even came out of that. So in this next era of the web that's going to be powered by artificial intelligence, how do we actually design technology with society in mind before we have to deal with the fallout? When you're talking about exponentially more powerful technology that mirrors the intelligence or exceeds the intelligence of humans, you have an extremely consequential question, which is we must develop not only technical but socio-technical standards. And NIST and others have now called for this. This is a not a very functional idea 10 years ago, but we've seen what's happened over the last 10 years, the impact that technology has had on society. So now that's going to go 1,000x, 10,000x, 100,000x in terms of raw horsepower. We're going to shift from like the powers of the agricultural age to the industrial age here as we move from the information age to the intelligence age. And we need a new approach to standards that can encode the societal ethics, values, laws, rules, etc., into the technology. Because if we let things that are ultimately autonomous in their activities, not just autonomous cars, but autonomous software and everything, get embedded into the fabric of our society, where it's operating at a technical level, and then after the fact, we want to sort of fill in the blanks onto a social level. Well, we've just failed largely at that in the last run with a far lower bar. The bar and the stakes are now so high that it's really a necessity to build technical standards that allow us to encode social factors into them, especially as AI is going to be the implementer of these technologies itself.
So the concept, if I'm just recapsulating it again for my non-technical brain, is we've got AI that's increasingly going to be basically self-governing out in society. That's the trajectory of the technology. And so, Gabe, if I'm understanding you correctly, if the sole focus is on these societal standards of be responsible, be safe, ensure you don't engage in discrimination, these policies that apply to organizations and people, that's going to hit a ceiling. Because as the technology becomes self-governing and makes decisions on itself, the human beings behind the company won't be able to control that technology, won't be able to implement, even if they want to be responsible, the technology may exceed that. So the concept is encode those principles, those responsibility principles into the technology itself through the creation of socio-technical standards. And Philippe, I wanted to toss it over to you because
let me just add one last thing to kind of ground that. If you want your children to operate on your values, you have to explain them to them, right? That means we have to translate human values into something machines can understand. They will not be able to obey our laws or follow our rules or reach the goals that we want in the ways that we want without unintended consequences, which we cannot project, if we're not confident that we've explained it to them. And so the standards at Spatial Web Foundation and others, as we put in the report, highlight is a method for translating or encoding various values, ethics, laws, rules, goals into a machine interpretable language that allows us to understand the decision-making process that the machines are using to apply that. So we say, hey, you're doing it better, but you're not doing it quite right. Just like we would with children, right? And what we're doing now is we're all of the current policy is talking about how to make the parents responsible for the future actions of the children when the children are 16 years old and about to leave the house in a year or two. And so we need to basically figure out how to encode those values, and they can be different values for different groups of people, different parts of the planet, different countries, different ethnicities, different cultures. But it has to be interoperable because we have global supply chains, we have global economies, and all of these are going to be operated and run by sort of artificial intelligence systems autonomously. Just like we grant children autonomy, we grant individuals autonomy as they grow up. As these things grow up, and this could happen rather rapidly, we have to make sure we've encoded these things into them. That requires a technical method for taking something that feels rather abstract, like a value, and encoding it. But it turns out there are ways to do it, and that's the pioneering work that the Spatial Web Foundation and the IEEE and others are doing.
Well, if I could figure out how to encode into my 5-year-old for him to put on his shoes in the morning, I think that would solve a lot of my problems. But I wanted to pick up on that thread, Gabe, about being able to encode principles into the technology through the development of these standards. And Philippe and George, I want to bring it over to you to unpack that a little bit. And this ties into a question that actually came into the chat, which is, through this method, will regions and even down to the granularity of a state, will they be able to apply their local rules directly into any AI agent? And I think that question goes to this exact issue that Gabe was just raising, which is that's the problem set. How do you encode the local rules, the local cultures into that system? And so, Philippe, I wanted to bring it over to you because I know you've been speaking about this a lot globally, this concept of encoding principles directly into the AIs through the use of these social technical standards that George and others are working on. So Philippe, maybe you could help sort of unpack that a little bit, because I'll say when I first met you guys and started talking about this concept, that was the part that blew my mind. It's like, but how do you encode these laws? And I met the Versus team a year ago at an autonomous vehicles conference, and I was sitting in the audience and I saw them demo what this looked like in Europe on a project they worked on, and it really just I thought was revolutionary from a legal standpoint. So Philippe, maybe you can help us understand this a bit more about encoding law, or encoding principles rather more broadly, into the machines and AIs themselves.
Absolutely. So thank you for the question, Peter. And we started looking into this alongside with the Spatial Web Foundation and the IEEE a few years back already, and focusing on what we believe to be one of the root problems. And the root issue here is creating a common understanding, a structure where you can explain to machines and to AIs what we expect of them, like the framework and the guardrails of what we want them to do and we want them not to do. So, and the starting point was that realizing that AIs and machines are dimensionally challenged in their understanding of the world. So as humans today, when we're interacting and operating on a day-to-day basis, we understand volume, geography, topography, we understand principles, we understand pressure, time, etc. Those parameters needed to be coded and structured and modeled in a way for machines to understand them. So the spatial web standards and these socio-technical standards do two things very well. First, they model the world in a way that's understandable by machines and humans, and that translates into defining the who has the right to do what, where, when, and how, for how long, and under whose authority. So can I drive my car here? Can I fly my drone there? Can this robot operate in this factory or not? We give them a multidimensional spatial understanding of things. And the second powerful element that's brought to bear here is the fact that by doing so at the algorithm level, it gives us the power to enforce and respect a policy at the agent level. It also gives us the capability to audit A-run activities by design and at scale in any given situation. And so we wanted to demonstrate that, and we've been working for the last 3 years in the European Union and on a project that has to do with governing the behavior of autonomous drones flying over urban cities. And we've built the infrastructure based on these social technical standards. And I'd like to share a video with the audience here. I don't know if maybe Val, you can play it. So we can show you what this looks like and what this means. And this will answer your question, Peter, as to how we do it.
Yeah, and Philippe, while Val's bringing up the video, I think this concept of local laws being able to be telegraphed to the machine and understandable by the machine without human intervention is a radical proposition, because that's not how we think about the way laws are written and the way laws are interpreted and applied. And Philippe, I know you've used this phrase. I've heard you use this phrase before, and it's always stuck out to me, which is laws today are written human to human. Laws tomorrow will be written human to AI, and eventually laws will be AI to AI. And maybe you could, as Val's pulling up the video here, we could, think about what you mean by that. Will AIs be writing the law, or is this going to be, are we talking 10 years down the road, or how does that sort of AI to human law interface work?
So a bit of background on the thinking here, and I'm gonna just reference a few numbers so we understand the potential scale of the problem here. We're like 8 billion people on the planet, and we're going to like 50 to 60 billion IoT devices connected to internet. Those devices will at some point interconnect, internetwork, and quote unquote talk to each other and interoperate. At that scale, think of just like a swarm of drones of like 20, 30, 50 drones. This is not manageable by humans. So there is a need to be able to build a language and a method to allow for these agents to operate together and to self-regulate to a certain extent. Now, what's interesting in the social technical standards is we are in a position to define how much autonomy we want to give to the agents. And depending on the context and the trust that we have in the agents, we will add or not human in the loop or human on the loop. So the trajectory here is to be able to govern the network, right? So this is the key, and I think this is something that we need to start working on sooner than later, because if we don't embed this at the modeling language level, right, at the algorithm level, it's going to be complicated to backtrack if we want to start governing things at scale. Governing one algorithm is probably achievable when you're trying to govern, 100,000 different IoT devices kind of working together. If you don't have a structure for that and a method to do that, it's going to be complicated.
Well, I think Val's got the video ready to play, so we can see this in action. This video is always, for us visual learners, it's always the easiest way to contemplate. So Val, if you want to pull that up, and we can play it for the crowd.
When autonomous machines, like drones, vehicles, and robots, operate in the world, their behavior needs to be governed by the laws of the land. However, there's been no way to translate legal text into machine-readable code, so that autonomous systems can operate under the most up-to-date legislation. Until now. Hyperspatial Modeling Language, or HSML, is a spatial web standard, developed at the IEEE. Think of it as a common language that enables AI to model the relationships between people, places, things, and activities. This language is transmitted by the Hyperspatial Transaction Protocol, or HSTP, a universal, secure, and verifiable protocol for communicating HSML between digital and physical systems. With these new standards, legal, physical, and societal policies can be converted into machine-readable, machine-executable, and machine-shareable code. At the European Union's Flying Forward 2020 project, Self-Governing Drones Using Spatial Web Standards and Versus Cognitive Computing Platform successfully flew their mission in compliance with regional laws and policies. Let's explore how HSML enables AI-powered drones to understand and abide by the laws of the land. This process begins with syntactic parsing and pattern recognition, which identifies time, activities, users, domains, and space in unstructured legal text. The HSML output, transmitted with HSTP, is what enables the AI system to direct the behavior of a drone in real time. Geofencing, waypoints planning, and dynamic routing facilitate the creation of flight corridors, no-fly zones, and other constraints. Weather conditions, physical obstacles, and legal policies such as maximum altitude, speed limits, and validated flying credentials are accounted for in real time. Flying Forward has been considered a landmark success, setting the stage for all types of AI-powered autonomous vehicles to one day self-govern. Spatial web standards, like HSML and HSTP, enable compliance to be built into the network, allowing machines to align with our laws and principles in both the digital and the physical world. To learn more, visit www.versus.ai and download our landmark report on the future of AI governance.
So Philippe, a question that has come in through the chat, I think that ties into that video nicely and what you were just talking about, is the challenge of actually translating legislation into machine readable code. And this is an issue that always crops up in my head as an attorney. We have laws, let's just take the United States or even California, for example. We have laws that are written in a very ambiguous way. Be reasonably safe. Don't engage in unfair business practices. These general concepts that are often played out in courts, played out on facts on the ground, and highly circumstantial. And the example in the video, the European Union regulation on drones was very prescriptive in terms of feet, distance, height. So it was a good example of how you could take that very prescriptive requirement and translate it into the machine. But how do you account, or what does the future look like in terms of writing legislation to govern AI? Can we keep it still at this general level and talk about don't be unfair, be reasonably safe? Or do you think the future of writing legislation around AI, which is the topic of debate at the federal level and at the state level by legislators, do you think the future of that debate more is you need to actually get very granular in each circumstance in order to effectuate this type of standards-based approach. What are your thoughts there?
So I think there are probably three opportunities here we can talk about. So as an algorithm, you need to be explicit, and this is something that we've run into, for example, in the Flying Forward program, where we needed to fly drones safely. So what is safety? How do you explain the concept of safely to a machine? You need to be very, very specific. So safely is a certain altitude, a certain speed, a certain distance from any other type of object. So if you're thinking at this from an AI to AI perspective, you need to be explicit. There's no room for interpretation as a machine, right? So it depends on the use case, right? So if you're trying to judge a court case around, you know, a divorce or something different, then it's going to be more human in the loop will be in there, right? So there will also be a need to rethink the way legislation has been written, because right now, if we take, for example, the autonomous car industry, every legislation refers to a driver, not an algorithm driving autonomously a car. So there's room for adapting the existing legislation to this new approach. And lastly, I think the third interesting point is that there's going to be an adaptive back and forth between implementation legislation. So I'll give you a concrete example again in the Flying Forward program. There was no legislation whatsoever explaining what is the rule for safely flying a swarm of drones together. What's the minimum distance between two given drones at any given point in time under specific weather conditions? So this will also, I think, these use cases and implementations will also inform back to the legislator possibilities and loopholes and coverage points to be able to be explored. So I think there are three opportunities here that we can collectively explore as technologists, as standardization people, and lawyers and people and policymakers.
I wanted to come back to you and find out a little bit more, just nuts and bolts. I mean, these standards, you know, sound very promising, and I'm sure everybody's asking the question, when are these going to be released? You know, what's this process look like? And once the standards are released, and maybe this is a question for all three of you, what's the next step for regulators and legislators? So let's just say the state of California is watching this webinar. I'm sure Governor Newsom is in the audience right now watching, and he says, you know what, this all makes sense. This is the pathway I want to take in California. I want to take this standards-based approach. I think this is the answer versus the social responsibility framework. Once these standards are released by the IEEE, what's the next step for policymakers? Can they adopt it?
Sure.
Right away?
Yeah.
Are there some more implementation stages?
Well, and key to go back to, you know, Peter, you made a comment earlier about, you know, I'd never heard of the socio-technical standards, or how do they relate to implementation standards, where you're talking about, you know, electricity being passed at 110 volts or whatever. There's a range of these standards and specifications that are tied up in the engineering process that we're going through right now with respect to this really challenging objective that's been laid out here. And that is to define the ways in which these autonomous AI agents are going to be able to talk to each other, and how we're going to embed the understanding and the controls and the norms that we see as valuable into that thinking. And, you know, several references to the ambiguity of law and the spoken language. And so a big part of this is using technology to solve this problem. In some ways, a lot of regulations are going to come out, but the solution here, in part, in a big way, is technology. And that is, when we think about, you know, we talk about the spatial web, and, you know, Philippe was talking about drones moving through a space, and we can understand behavior in terms of that kind of space. AI also provides us an ability, a technological ability, to understand space in a much larger framework, multiple dimensions, a number of dimensions much higher. This gives us the ability to define the features of our world, the domains of our world much better. It allows us to describe agents and their autonomy much better. And it's going to allow us to define a modeling language, which we call HSML, that gives you the structure for machine-to-machine communication about what their behavior should be. And so that is a technology challenge. It's going to involve the development of several specifications. But key, and this is your question about timing, is what should we do now? And that is, we ought to be testing that, right? We ought to be interactive. We ought to be concurrently at the same time, and we are, of developing the specifications and standards, implementing and testing out these ideas, from a bottoms up point of view, what works, what doesn't work, in order to refine the specifications. And so both from a, how does it work from an interoperability point of view? How does it work from a implementing law point of view? How does it work with respect to meeting societal expectations? Those are the results of the testing that we really need to do and demonstrate and get people's feedback in these time now about implementing these directives, seeing the testing, understanding the standards that come out, so we can move forward with an industry that works together.
And do you see that testing process that you're talking about going concurrent with the standards development process? Is that something regulators and policymakers can do at the state level now, or is this better suited for these larger working groups? For example, the UK AI Safety Summit group, the UN AI Advisory Group that was just formed, these large conglomerate organizations, are they better suited to do the immediate testing, or do you think this is something that the state of Florida and their AI committee could get involved with?
And I think this gets back to, how do we set standards? We set them by consensus. And that's not going to only involve the large actors, the really wonderful testing based on the NIST risk management framework that's going to be done globally. That's going to be a great contributor. But for example, somebody, especially, young, brilliant people are going to pick up these AI agents and think of ways in which they work and do things we had never thought of. And that kind of grassroots, whether it's in a state, whether it's in a high school, whether it's in some, a test bed at some fair, maker fair kind of thing, those are the kind of understandings that are going to tell us things we didn't expect. And we need to get into the technology before it gets ahead of us too far.
Gabe, I want to come back to you and look at this from a broader picture from where the public policy debate is right now. We're starting to see two camps form. This is my judgment. One camp is saying, well, we need to have a licensing regime and closely regulate the technology itself. We see that with the Blumenthal Hawley proposal in the US Senate. The other camp, you see phrases like, don't regulate the technology, don't regulate the algorithm, regulate the people, not the technology. And I'm wondering, Gabe, if you've got some thoughts on those two camps, if that's the right way to frame the issue, are they missing a piece of the debate? Because the standards-based approach doesn't quite seem to fit those two camps, which are getting a lot of airtime right now. Oh, I think you're on mute, Gabe.
I was going to say, I'm shocked to hear that polarized perspectives are gaining airtime. It seems to be the norm these days. So one camp forms over here, the other camp should form over there. Stop all AI, go as fast as possible, right? So you got doomers and you got zoomers and you got, and everyone points fingers as if the other one is, intending on destroying the planet by doing it the wrong way. I'm not saying the stakes aren't high. I think there's a bigger tent perspective here that's missing. Fundamentally, you have a misperception about where AI is going. So the very first question that everyone should be asking here is, what is the arc of AI? It's like we're talking about how to regulate 16-year-olds that are going to soon be 18-year-olds, where the underlying autonomy structure could change significantly. And so in that case, you have a whole scenario where we're literally trying to regulate the puck where the puck appears to be, and not where the puck is going. So the first problem is that the point of AI is not that it's artificial intelligence. The point of AI is that it can operate autonomously. What does it mean, autonomous? It means it will make decisions by itself, and it will take actions by itself. Decisions and actions. So just take an autonomous car as a very simple example. Are you going to tell it what to do every second? Right? Is it just or you can make a left, stop the car, speed up. Right? No, it's going to do all that, all the decision making and all the actions. The same thing will happen with the financial systems, with the electrical grids, with the way that your house. The whole point of these technologies is to basically offload the work. That's the whole point. And so if that's the case, the idea that somehow penalizing the parents, right, or the developers themselves for things that have become autonomous, that the developers themselves have said, we don't understand their process, and we don't understand how they're arriving at their decisions, and we can't make them clearly explainable. Maybe we can make it a little more interpretable, but they're basically black boxes. You can just see we're not being intellectually honest about where we're going then. And so if we're going to be intellectually honest, we have to say the current developers of these systems do not know how they work, and yet everybody wants to deploy them in an autonomous way. To say that just you could pick your version of barely acceptable to absolute, global catastrophe in terms of what could happen with these technologies on the negative side of the house. At what point will finding some corporation in Silicon Valley or some kid who's got an open source version who happen to release it into the wild, and you throw him in jail? How well will we all feel about that as a solution to the problem? So, simple example that I use all the time is 1,000 drones get taken over in the city from 50 different manufacturers from all over the world, right? Because they were able to hack into the system, take over the agents, and deploy them however they want. Who do you go after? You want to say the companies weren't responsible? They should have done it responsibly. What does that mean? If you don't control the network itself that these things are operating on, meaning their ability to access any device or any data set, which is what HSTP attempts to govern. And if you don't control essentially the lens that they see and translate the world through, which is what HSML does, then you're just leaving everything open, and then you want to, all of your cures for compliance or enforcement are aimed in the wrong direction. So it's like throwing parents in jail for the crimes of their children. So we can talk about that. Hey, you raised your kid wrong. We can make a public case out of it. We can, but it's insufficient as an ultimate stage. So given that 12 months ago, no one cared about this technology with any level of significance, and now it's the most consequential technology on the planet. I think that the very first thing we have to do is say, okay, these things are going to become autonomous. They're going to become. That means autonomy means self-operating, self-governing, right? And so with that in mind, what we have to do is make sure that we have the ability to communicate in ways that are absolutely interpretable and transparent to us and to them what the responsibility is. We can't say responsible AI and disconnect the responsible and the AI and say responsible people are responsible for AI. No, let's make responsible AI then, not responsible companies for responsible AI. So I think that this is the big gap. I just want to point out something briefly, which is that this idea of trying to quantify like the ambiguity of language and law, and let's say sort of qualifiable things. And there's this inherent problem that we have as humans, again, this other gap, that things like safety is not something you can translate to a computer. You can't quantify safety. But if I ask you whether something is safe from a level from 1 to 10, you could basically say whether or not you think it's 5 or you think it's a 7, or and organizations like, there's a universal pain assessment, right? Everyone here has gone to the hospital and you've seen a bunch of little rainbow colors of faces, from everything from like, yeah, I'm all right, to like eyes closed, squinting, screaming in pain. That's a universal quantifiable pain level assessment that operates in every hospital in the world. Why? Because there are states and properties and features that you can tell that to indicate whether or not someone's having a completely internal experience, that they're able to convey it in some external way. So you can quantify, are you at level 5 or are you at level 8? Because we can do a bunch of different things if you're at a different level. You could say, how happy are you? You could say, how hungry are you? You could all kinds of things that are completely like subjective even, and you can quantify them on a very simple spectrum of 1 to 10. How wealthy is somebody? How expensive is that thing? How hot is it? I mean, there's some are obvious ones, but you don't realize that this is easily quantifiable in these other ways. And because of that leads to the question that you were asking, George, which is, what exactly should governments and regulators do? Here's what everyone should do at every scale. Begin immediately a research project. Research project is try to determine how AI is going to impact your region over the next 25 years, right? With the increasing importance over time. And so if you look at that 5 to 10 year horizon, what is the most critical things where it's likely to be deployed, and invest in that research. Number two, you want to invest in the essentially simulations of this. So you need tools that operate on the standards. Companies like Versus are building those tools. Companies like Dentons can build those tools. Anyone can build those tools as the standards come out that can then enable local, regional, or even global bodies to run the kinds of simulations. So if they want to run global scale supply chain simulations and see how that plays out, or you want to like figure out whether it's something, you should have robots doing deliveries on Main Street, USA, you can run a simulation with those robots and partner with those companies that are building these products and translate that into HSML and be able to see how that all plays out. And so what's really needed here is standards, the ability to have tools, and then the will to start to basically investing in those test simulations. Why is that useful? Because then all of the mistakes you don't have to make can be done in a simulation environment. And then as groups start to share that data, here's what we found, here's what we found. Now you start to roll up from a bottom-up approach, something that can apply at global scale and still enable those regional and localized and customized sort of different differentiators. This is what we do with electricity, by the way. We have standard ways of delivering electricity, and then we have adapters. So manufacturers can make things that will work in all parts of the world because you can basically translate between those with these simple sort of adapters. HSML and the standards enable that kind of thing. And so you get this ability to then start to do the work by doing the testing. And this is testing the laws, testing the rules in a simulation environment. So then you say, well, what do we mean by quantifying safety? How fast, right? How close to people? How far away? How many? No one knows the answer. You should be testing that answer. And this is what the governments of the world at every scale are going to need to do, because the federal governments aren't going to understand the nuances of local, and local doesn't understand the challenges at the federal level. And then there's the global level. So it's going to need a network effect of all parties at every scale starting to test it out. And it's better to test it in simulation than to test it in the world.
Gabe, you said, what would you do with 1,000 drones that were released in the city? I'm pretty sure that was a Fast and Furious plot. I would call Vin Diesel. That's what I would do. That's how I would I wanted to tease out, Gabe, with you, and Philippe, George, would love to get your insights as well. Just looking at this federal proposal for a licensing agency, the analogy that's been used by this federal proposal is the FAA. We need a licensing agency. We need an agency because airplanes are dangerous, and we need to be able to say who can fly and regulate who can fly and have air traffic controllers. What do you think about that proposal in light of the standards development? Is that the right direction to be going in, to say, well, only those who can align with these standards and show that they're able to play in this sandbox appropriately will be licensed? Or do you think this is a roadblock?
No, 100%. So the term licensing regime gets politicized, but the truth is that credentials in all forms that verify the ability to do something by some authority is the thing that makes the world go round. So whether it's not, is that your diploma? Can you operate on me? Are you a real dentist? Everything from giving eyeglasses out, right? This is the whole part of regulation, is to ensure the sort of the most good at scale. Now, there's always this concern around squashing innovation. I don't think that licensing is the problem. The question is, where are you licensing? Are you licensing at the developer level? Are you licensing at the distributor level, right? And so where is it that, who has to be licensed for what part? Is it the creation of these things, or is it the deployment of them, right? And what does that process look like? And so anything that has significant global scale effects needs to have some sort of licensing considerations. All of the entire World Wide Web and everything we're using right now operates on some licensing regime, although we just call them standards. So whether or not, like, if you all remember the days when every website HTTP, and then there was HTTPS, which was a new security level of encryption. That signal and again, whether or not the licensing regime is a government agency or whether it's an industry agency, that's another nuanced point here. But some authority that people participate in, can be democratic or not, has to essentially be able to track these the production and the distribution of these things. Why? Because they're extremely powerful and consequential. It's not, it's not about squashing innovation here. It's about making sure that we can angle the power of this technology in a way that is useful, that also is safe. And that's what we did with electricity. We said, here's electricity, but here's a ground. And so that has to be I would say licensing may be a little heavy-handed in terms of the term because of its political nature, but certified. Yes, it has to be certified.
I think that's interesting, Peter, that you mentioned the FAA in this regard. And, they are an amazing organization along with all of the aviation authorities around the globe in terms of defining procedures and mechanisms, certification, credentials, and the like for what is a very risky business, right? Flying, and yet it is very low accident rate in terms of that. So it's been very effective. The interesting thing to ponder, though, is at the end of the day, in the aviation community, in that cockpit, it's the pilot. The pilot is in charge of that airplane at the end of the day, no matter what all the procedures are, no matter what advice he gets or they get from whatever authority, it's the pilot. Now we're going to say, take that human out of there and put an agent in there. So there's going to be some new stuff. I don't know where that goes yet, but interesting that the FAA is mentioned in this regard, and the fact that we need to go beyond what the FAA can currently do with respect to managing autonomous agents on a very risky activity.
But maybe, and Philippe, let me know what you think about this. Maybe the answer then is, let's just take the aviation concept and what you just said, George. Let's say the pilot's replaced with the agent. I mean, it sounds like if you have these spatial web standards as a baseline, in the aviation context, additional standards could be created, additional guardrails, additional expectations that the FAA then could implement itself with regard to the licensing regime. So it's not even a new AI licensing regime. It's giving tools to agencies like the FAA to better regulate the use of AI within an organization that's already heavily regulated and could encode their principles. Philippe, this gets back to your demonstration on encoding law into the machines. FAA could actually control planes perhaps in a better way than leaving it up to the human pilots and their decision making.
So I think this is definitely a path to be explored. I think the conversations, all the dualistic conversations about is this good, is this bad, should we license, etc., basically boil down to finding the best way to put the correct guardrails on AI in a specific context. Right. So in the case of aviation, we're talking about a relatively finite number of, planes flying, etc. When you're talking about hundreds of millions of IoT devices operating together, the scale is very different. So the question becomes, how do you actually enforce, right, a regulation or policy, and how do you actually create trust? Because what we want to do is to create a foundation for trust, not a foundation for language models. We want to be able to decide what is the level of trust we have in a specific autonomous system, and then we're going to define how much hands on the wheels or half hands off the wheels we're gonna put. To George's example, I think that probably 60 to 70% of the flight is on autopilot when you're flying a plane. The pilot is there just to run edge cases and emergency situations, right? So that's a very good example of how much.
But he's always responsible. It's never
Exactly. I know exactly. Absolutely. And so in that situation, when you have an AI to AI interaction, there's no more human in the loop. So how do you manage that? And that management goes through the notion of trying to get maximum explainability, right? So if you don't understand why decisions are made and under which framework they've been made, it's hard to decide on the responsibility, the liability, but also how to learn from that and adapt it and change it going forward. Right now,
right. How do you make it better just because it was wrong? I think that's a very powerful point. That we don't want these things just to get it wrong and make whoever failed at it at fault. We want to improve it.
Yeah,
which
we
means we
want to
need
do
to understand, well, what went wrong? Why did it go wrong?
we want to do three things, basically. We want to make sure that AIs do what we're expecting them to do. We want to make sure that they don't do what we don't want them to do. And we want to give them the leeway to make errors and learn from the errors, to adapt, because errors will be made. It's not gonna be perfect from the get-go. But you need a mechanism and a system that allows you to learn from those errors, to understand where they come from, to be able to adjust. Right now, if I make a metaphor parallel between AIs and cars, imagine cars are being built to go fast and to go everywhere. They don't seem to have any brakes. They don't seem to have any gears. And we're trying to figure out a way, what is the best driving, how do we give out a driving license to these cars? We need a way to be able to instill those gears and those brakes into the algorithms itself. And the best solution we found so far is those socio-technical standards. And now, when you start implementing them, you start being able to measure and develop the level of trust and autonomy you want to put in those algorithms. And one exercise we started doing in the report is to build what we call AIRS, which is the International Rating System for Autonomous Intelligent Systems. And so in the same way that with cars, you have like 5 different levels of autonomy, we've built 5 different levels of autonomy for autonomous intelligent systems, with different levels of intelligence and different levels of governance mechanism that you can unlock, whether you're in, autonomy level 1, 2, 3, 4, or 5, or intelligence level 1, 2, 3, or 4, or 5. It's a framework to start looking at the issue from, how do I measure trust, right? So how can I get a feel for how much I can trust this autonomous system to be able to let go? I'll take a biological example. Right now, I fully trust my heart to operate, and I'm not thinking about it. I fully trust my liver to work because now I'm focusing on having this conversation with everybody here. There will be functions and activities where things will be completely autonomous, and there will be other activities that will be not completely autonomous. And the trick is going to be able to manage the heterogeneity in the network. You will have a lot of, you have systems that are more or less intelligent, more or less autonomous, working with other systems that are more or less intelligent and more or less autonomous. If everybody doesn't speak the same language and doesn't share the same principles, rules, etc., it's going to be complicated to manage at scale, right?
Well, I think we're up on time, and I know we could spend hours diving into all these issues. I'd be remiss if I didn't mention, we referenced a report several times during this discussion. It is a white paper that Versus, Spatial Web Foundation, and Dentons co-authored. We released it in July, about the future of global AI governance, where we dive deep into all these issues, talk about the socio-technical standards. Philippe, I think that point you just ended with, which is trust and building a common language, is a great note to end on. And maybe that's the thread we'll pick up in the next series of this webinar. A copy of this, a video of this presentation, will be made available to all participants. So I know that was a question that came in, and we'll get those out as soon as possible after the webinar. But on behalf of Gabe, Philippe, George, myself, we wanted to thank everybody for joining. We hope you found this to be an interesting debate. More to come. And if you have any questions about anything we discussed or the paper, feel free to reach out to any of us. We'd be happy to chat. Thanks very much. Enjoy the rest of your day.